I am in the painstaking process of wiring more stainless steel wraps around this transformer to try to balance the inductance. Alright, we've got another entire loop of stainless steel wire. We've got it configured just all as one continuous coil. Just a little bit higher voltage than last time. Maybe. But if we can crank this thing up to 32 volts, we only have half an amp input. We do have much more equal opposite, although we do have just a little bit more negative potential than we do positive potential. You can see that's just below that line, where this is just above that line if you're going that direction. So I do like the milliamperage at the cell. That is really low, but again, 80 volts really isn't going to do anything for those cells. Just can't seem to break that 75 volt threshold though with these stainless steel coils. I do, however, I want to dump 100 volts in this thing to see what it would do and see how high we can get it. Well, the stainless steel coils, I believe, reduce amp consumption, perhaps both at the cell and input wise, but also reduces voltage. The combined total inductance is 723 millihenries for the stainless steel coil. Resistance is 7.2 kilo ohms. Sweet. That's just fucking dandy. Well, that's it for today. Inconclusive. Definitely rained on my parade here. Not only the fact that, obviously we have this shorting out, but not accomplishing any greater voltage at the cell. Even though it's a similar configuration, we get less voltage at the cell. And we had to have more stainless steel windings, more inductance stainless steel wise, to balance the waveform compared to copper, which did not require as many winds or inductance to balance. It's very strange. Very strange properties.
This is Stan's Revenge.